Now that we've defined a complex number z equals x plus iy, where I was equal to the positive square root of minus 1, note that I squared is therefore minus 1. What we'd like to do now is define the inverse of a complex number. So our next step is to define 1 over z. Now, we can write this in the following way. If we multiply the numerator and denominator by the complex conjugate, where z bar is equal to x minus iy, then we saw that the inverse of a complex number is equal to, that's a 1 times z bar, is x minus iy over the modulus squared, which is x squared plus y squared. So we have a new complex number, if you like. This is equal to a plus ib, where a is x over x squared plus y squared, and b is minus y over x squared plus y squared. And that is our new complex number. Now, what's interesting here is if we plotted z, so if we have our y and our x, and if we plot z, then our complex number, if we go to x minus iy, that's the conjugate, but it's the length of this complex number is different because of that. Let's see what the length of this complex number is. So we want to take z, multiply it by its conjugate, 1 over z bar, and take the square root. And from our notation, we know that if we wrote 1 over z as a plus ib, then this is just a squared plus b squared to the 1/2, because we've written the complex number in terms of a plus ib. And we have our expressions for a, so we have x over x squared plus y squared, quantity squared, plus b, which is minus y over x squared plus y squared, quantity squared to the 1/2. And we have upstairs, we have x squared plus y squared. And downstairs, we have 1 over x squared. So this becomes x squared plus y squared over x squared plus y squared squared to the 1/2. And we have just 1 over x squared plus y squared to the 1/2. And so we see that the modulus of the inverse of the complex number is just equal to the 1 over the modulus of the complex number. So we can write that as 1 over z inverse equals 1 over z modulus.